Welcome back, everyone, to the eCoreAcademy e-learning platform. My name is AJay Raj, back with yet another Algebra 1 video for you all. And today we're going to be specifically looking at completing the square within the quadratics unit at the end of our Algebra 1 course. So before we get into the lesson, please make sure to do 4 things. Please make sure to hit that subscribe button, turn on post notifications, hit that like button on this video, and also feel free to comment down below. All of those things are greatly appreciated. So as I was saying, we're going to be taking a look at the completing the square method, a form in which you can solve quadratic functions. So I'm going to show you the entirety of the formula, go through the basic steps, and then obviously we'll go through simple practice problems so that you essentially get the skill down and you can practice it on your own, having seen multiple different scenarios. And then finally we'll end off the video with a basic word problem. It's something that's very common with completing the square when it has to do with geometry oftentimes, and obviously it's not going to be the easiest of problems, but I'm going to show you how to solve it. The only thing that really should take the work is the computational side, which is something that we all know how to do. You just have to be careful. All right, so without further ado, let's jump right into the video. So let's take a look at the steps to completing the square. So the very first step is that a must equal 1. Remember, we're going to be given equations in standard form, and we're going to be solving those standard form equations by isolating our x, and whatever x is equal to, that's our x-intercept. Those are the solutions for x. It can be 1 or 2 solutions, or none, obviously. So we're given this standard form equation here, 2x squared plus 24x plus 28 equals 0. And in this essentially this quadratic function in standard form, the first step that we have to do is we always have to make sure that the equation, the a value of the equation, meaning whatever is being multiplied to x squared, it must always equal 1 in this case. So since we have a 2 in place of a, obviously we have to make that equal a 1. So since 2 divided by 2 equals 1, we're going to divide this whole both sides by 2, both sides of the equation by 2, so that we get an a value of 1. So when we do that, we get x squared plus 12x plus 14 equals obviously 0, because 0 divided by 2 is 0. All right, so now we're going to move on to the second step. So now that we've essentially isolated our a on the as 1, and then we've kept our entire standard form equation on the left-hand side equal to 0, the next thing that we're going to do is the second step. We're going to isolate ax, essentially that ax squared term. We're going to isolate that ax term, and then the bx term on the left-hand side of the equation. So all we're doing is we're taking the c term, the constant here, 14, and we're moving it to the right-hand side so that the ax squared, essentially 1x squared, and the bx, 12x, are isolated on the left-hand side. Everything that has x in it is going to be on the left-hand side. So in order to do that, simply we're going to subtract 14 from both sides using the inverse property, and we're left with x squared plus 12x equals negative 14. So we moved c to the right. All right, now let's take a look at step number 3. Now we're going to make the equation a perfect square trinomial by taking half of b and squaring it, and then we're going to add the value to both sides of the equation. So this is more of the property of completing squares. This is the formula that you're given. So what we're going to do here is we're taking this b value, whatever's being multiplied to the x, the regular x to the first, that's 12, that's our b value. We're going to divide it in half and then square that value. And then once we square that value, we're going to add it to both sides of the equation. Now, why exactly are we doing that? Whenever you divide the b in half and then you square it and you add it to that side, essentially this left-hand side becomes a perfect square trinomial. And when you make it a perfect square trinomial, you can factor it out into a binomial. And when you make it a binomial that's being squared, you can easily square root that. But I'll show you that in the next step. So what we're doing here is we're taking our b value, it's b over 2 squared, essentially. So what does that look like? So 12 divided by 2 is obviously 6, and then 6 squared equals 36. So now that we've discovered what b over 2 squared was, we're going to add this to both sides of the equation. Remember, always adding. So we're going to add x squared plus 12x plus our 36 here, and that's equal to, obviously we have to add whatever we add to the left-hand side, we have to add to both sides, obviously. So 36 plus negative 14, that's going to equal 22 on the right-hand side. All right, so now that we've calculated that, let's go on to our last step, step number 4. So step number 4 is we're going to restructure the perfect square trinomial into factored form, meaning we're going to create a squared binomial. Then we're going to take the square root of both sides. Since it's a squared binomial, you can merely square root it, get rid of that exponent, the 2, and that's clean, not unlike, having a trinomial, which is a lot harder to do. And then essentially you're going to take the square root of both, and whatever's left, whatever is equivalent to x are your x-intercepts. So let's take a look at that. So obviously we have this equation here, x squared plus 12x plus 36 equals 22. We added our b over 2 squared, our 36, to both sides. So the next thing that we're going to do is we're going to factor this out. Remember, whenever it's a perfect square trinomial, that means you can write it as a binomial squared. That's always what a perfect square trinomial is. And how to make that, obviously I just showed you. You just take the b, divide it by 2, and square it, and then add it to both sides of the equation. So we're going to factor this out. So obviously here, you know that we divided 12 over 2, that's 6. So obviously we're going to add that to our x. So that means x plus 6 squared equals this equation. And that equals 22. So these two expressions are essentially equivalent to each other. So if you factor this out, you get x squared plus 6x plus 6x plus 36, which is x squared plus 12x plus 36. All right, so the next thing that we're going to do is, obviously, we have a very smooth property here. We're going to use our radical property. So we're going to take the square root of x plus 6 squared and the square root of 22. Remember, since this is a binomial and it's being squared, all we do is merely cancel out the exponent. So that means we're left with x plus 6. Very smooth calculation. And then on the right-hand side, for the square root of 22, obviously it's not just the positive square root of 22. This cannot be simplified any further, so we'd leave it as the square root of 22. But remember, you can always have a positive or a negative square root of a positive number. So it's going to be plus or minus the square root of 22. So now that we've discovered this, x plus 6 equals a plus or minus square root of 22. The last thing that we need to do is we have to discover the isolated value of x. So in order to do that, we're going to isolate x on the left-hand side by moving 6 to the other side. And we're left with x equals negative 6 plus or minus the square root of 22. And those are your two x-intercepts in this case. There's two solutions here. So it's either negative 6 plus the square root of 22 or negative 6 minus the square root of 22. And those are your two x-intercepts where the parabola intercepts the x-axis twice. All right, so now let's take a look at some more practice just like that, but we'll go through these a lot smoother, and literally I'll write them all out in a quicker pace. So let's solve the standard form equation by completing the square. So we're given the standard form equation x squared minus 8x plus 13. Remember, the first step is move c to the right-hand side of the equation, so subtract 13 from both sides. We're left with x squared minus 8x equals negative 13. The next step is obviously to take half of b and then square it. So negative 8 over 2 squared. Negative 8 over 2 is negative 4. Negative 4 squared equals 16. So we're left with x squared minus 8x and add 16 to both sides. Plus 16. And that 16 plus negative 3, that's obviously 3. So now that we've completed this part of the equation, the next thing that we're going to do is we're going to factor this out, essentially, or put it in factored form, a squared binomial. So since it's a perfect square, obviously it's going to be x minus 4 squared. That equals 3. And then obviously we're going to square root both sides. We're left with x minus 4 equals the positive or negative square root of 3. And then we move our negative 4 to the right-hand side of the equation, add it to both sides so that we isolate x. We're left with that x equals 4 plus or minus the square root of 3. So there's two solutions in this case, obviously 4 plus the square root of 3 or 4 minus the square root of 3. Those are our two x-intercepts. All right, now let's move on to the next problem. We're given this equation here, x squared minus 2x plus 6 equals 0. We're going to move 6 to the right-hand side, obviously. So x squared minus 2x equals negative 6. Then, obviously, we're going to take half of b and square it. So negative 2 over 2 equals negative 1. We square negative 1. That's going to equal 1. So it's x squared minus 2x plus 1 equals 5. How do we rewrite that? Obviously, it's x minus 1 squared equals 5. Then we're merely taking the square root of both sides. We're left with x minus 1 equals a positive or negative square root of 5. Then we add 1 to both sides to isolate x. We get that x equals 1 plus or minus the square root of 5. All right. Now let's take a look at a challenging word problem. Obviously, this seems quite wordy. When you break it down into simple bite-sized chunks, which is a very hard skill to do, but I'm going to be showing you how to do that. But once you split it up into different sections and you solve them separately, it's quite simple and straightforward, these word problems. So this word problem is all about a hedge maze. So near a town park, there is a massive hedge maze that has a total area of 5,616 square yards, including the walkway that goes around it. The length of the hedge maze is only twice the width, and the walkway surrounding the maze is 2 yards wide. So what are the dimensions of the maze? So if you look at the info given, we're given a hedge maze, essentially like a regular maze that you go through. It's made out of, those hedges, those giant bushes essentially that are shaped out. It's a giant hedge maze, and it also has a walkway that goes around it. Now, the walkway and the hedge maze together is 5,616 square yards. However, for just the hedge maze alone, excluding the walkway, the length of the hedge maze is only twice the length of the hedge maze is twice the width, essentially. And once we get that property, we can solve for it. And the walkway itself is 2 yards wide. So we're given all this separate information. Now, what exactly can we do with it? Well, the first thing that I would do is, this is basically a geometry problem that we're putting into algebraic term. So let's draw it out. So we're given that walkway and then that hedge maze. Obviously, this is our hedge maze, and the green part is our 2-yard walkway. We're also given the info that the combined area of the entire contraption is 5,616 yards squared. What we're trying to look for is the dimensions of the hedge maze. So what is the length and what is the width of the hedge maze? Now, we're going to start off with the simple property of creating an equation. Now, in order to put in terms of the length of the hedge maze, what are some things that we know? Well, the combined area is 5,616 yards. So we have to start here somewhere. We know that length times width is going to equal the area. So we can start with the area. We know that this entire contraption here is 5,616. So that means the length of the hedge maze plus the 2 yards of walkway on both sides. So that means we have the length of the hedge maze. We're going to call this our x here. Obviously, if we refer back to our word problem here, we're given that the length of the hedge maze is twice the width. So length is twice the width. So here we're going to leave, we're going to call this our length. We're going to call this our width here. X is going to be our width. And we know that we have a 2-yard walkway that goes along each side of the hedge maze here. So this side is going to be 2 yards, and this side is going to be 2 yards. So that's going to add to the width. So that means the entirety of the width is going to be x plus these 2 yards on both sides, which is going to make it x plus 4. So our width is going to equal x plus 4. And then, of course, for our length, we know that the length is twice the width, and we named the width x for the hedge maze specifically. So it's going to be 2x for the length. And then, of course, we have the 2 yards here on this side for the walkway, and then another 2 yards on this side. That's going to be 2x plus 4 now, adding those 4 yards of walkway. So this is our width, and this is our length. Now, all we have to do is put this in terms of 5,616. We know that length times width equals the area of a rectangle, so we're going to multiply these values together. So 2x plus 4 times x plus 4 equals 5,616. Now what we're going to do is, obviously, we're going to multiply this out, so we're left with 2x squared plus 8x, plus 12x plus 16, and that's going to equal 5,616. So I'm basically going to rewrite this, move this down here, so it's a little bit larger here. So 2x squared plus 12x plus 16 equals 5,616. Now remember, what we're only trying to calculate for is essentially what's going to equal the length and the width. Now, if you think about it, 5,616, that's the entirety of the contraption here, including the walkway here, this entire diagram. Now, we realize that this plus 4 here, these two plus 4s, that's essentially the length of the walkway, and that's the width of the walkway that we're adding to get our 5,616 that we're multiplying together. Now what we're going to do is we merely multiplied the length 4 by the width 4 to get 16. That's going to be the total area of the walkway, because we just took the length here, 2 yards and 2 yards, and then the width, 2 yards and 2 yards, multiplied it to get 16. So now what we have to do is we have to subtract that 16 from both sides. When we do that, we're left with 2x squared plus 12x equals 5,600. Now we can literally start our process of completing the square. So next thing we're going to do is obviously we have to make sure that a is equal to 1. So we're going to divide both sides of the equation by 2. We get that x squared plus 6x equals 2,800. All right, so let me clear the screen a little bit so that we can move all this info up to the top. All right, so we're left with, we have the problem x squared plus 6x equals 2,800 in this case. So since we have this equation here, we can start completing the square. So we're going to get that perfect square trinomial, that step number 3 that I talked to you about. So we're going to divide b by 2, 6. So 6 divided by 2 is 3. And then when you square 3, you get 9. So we're going to add 9 to both sides of the equation. So that's x squared plus 6x plus 9 equals 2,809. And obviously the next thing that we're going to do is we're going to make this a perfect square, essentially a squared binomial, this perfect square trinomial. So we're going to factor this down. So this is going to be x plus 3 squared equals 2,809. Now, obviously, we're going to take the square root of both sides of the equation. So we're left with x plus 3. And the cool thing is 2,809, that's actually a perfect square. That's going to equal positive or negative 53. And obviously, the last step here is going to be x isolated on the left-hand side equals negative 3 plus or minus 53. Now, we're actually not done here. We have digits here, negative 3 plus or minus 53. We can simplify this down further. So what we're going to do is we're going to see what the two solutions are. So the two solutions are that x equals negative 3 plus 53, or x equals negative 3 minus 53. So let's simplify these. So that means that these are the two possibilities for the solution to this diagram. We have to check which one is right, and then we have to put that down as our answer. So that means that x equals negative 3 plus 53. That means that x equals 50 yards. That means our length is essentially our 50 yards in this case. That means our width is going to be 100 yards. Well, that seems fairly reasonable, and if we multiply that together, it literally adds up to 5,000. That's what we want. Now, we always have to check this second equation just in case there is some sort of issue. Even if we didn't have a logistical problem, like we know that this is going to be the right answer. Sometimes in math, obviously, you don't have reasoning behind it. You just have to find out which answers are right. So we have to simplify this down. So x equals negative 3 minus 53. Well, it's already alarming that negative 3 minus 53, that's negative 56. And you cannot have a negative distance in yards. You can't have negative 56 yards as your width in this case. So that means that this guy right here, this equation here, is correct. So that means the length, or x, is going to be 50 yards, and then our width is going to be 50 yards, and our length is going to be 100 yards. All right, everyone. So I hope you all enjoyed this video. This has been the eCoreAcademy e-learning platform. Please make sure to like and subscribe down below. Check out our website at www.ecoreacademy.org. Email us if you have any questions at ecoreacademy@gmail.com. Check out all of our socials at Pinterest, Facebook, Twitter, Instagram, and TikTok. If you have any questions, you can always reach out to us through any of those platforms, and also check out what kind of cool content we have out there as well. I hope you guys enjoyed this video. This has been AJay Raj, and I'll see you guys in the next one. Peace.